Morning, YouTube. Um, so do a quick introduction. Um, been a technician for 15 years. Started back in 2008, and I love the field. Just don't I don't I don't agree with pay, but that's just me. I know a lot of people are on the same boat, but um, what I didn't make this channel for this, but I decided I was gonna open up, revamp my YouTube channel, and start running these diagnostic procedures with you guys. Um, I know you don't learn this in school. You don't even learn this kind of stuff at the specific maker. If you work at a dealership, like say GM or whatnot, you don't get this kind of detailed training. You don't learn this kind of stuff in class. You can learn some stuff, but I felt I could explain this better for you guys to help you. So here we go. We'll start. We got P146D on a 2020 Chevy Blazer. All right. So now I know you guys, a lot of guys will look at all this stuff and get intimidated. But let me walk you through it. And these are all my videos that I post. They're all verified fixes. Okay. Um, and 9 times out of 10, I do 100% pinpoint accuracy. What I can tell you to try to help you is reading. Yeah, reading is a must, but your comprehension is on top of that at 150%, because if you don't comprehend what you're reading, you're not going to figure it out. Okay, so let's go over this piece of paper. If you got Pro Demand, you can find this information. You just look under OEM testing. And you always want to use the OEM testing because this is straight from the manufacturer. So this is their system. This is their circuit. So, excuse me. So here we go. You see the checklist here, right at the top. Diagnostic instructions. You want to perform the system check. And for GM, you have to have a good battery. You don't have any other DTCs that have to be diagnosed before you diagnose this code P146D. Okay, so that's that. So the descriptor here just gives you an idea of what's going on in the system. So in this case, I'm going to highlight it. Not highlight it, but I'm going to underline it. Got 146D. It's telling you that the purge system pressure sensor has got low voltage, right? So this helps you narrow what you're looking at. So you only want to focus on the 146D. So now you look at this chart right here where it says diagnostic fault information. And basically, here we go. 146D can be a signal short to ground. It could be an open, high resistance at the signal circuit, and also your 5-volt reference circuit. And you see how we're not focused on the E, the 641, so we have a general idea. It could be you could have an open in the 5-volt reference circuit, the signal. You could have an open, or you could have a short to ground on the signal circuit. Okay, so boom, you're on a good run right here. Okay, so now when you look at the scan tool data, you got your whatever scanner you're using. This is your typical data for the evap purge pump. So if it's got a short to ground, like it says here, you're going to get 0 volts on the 5-volt reference. On the signal circuit, you're going to have 0 volts. That's what the scan tool is going to say, or that's what it's going to show. Even if you have it open, you're going to have 0 volts. And if you do have it open, the low reference is going to show 4.9 volts. Okay, so this is how you basically gathering information. So now if you got a short to voltage, it's going to show 4.2 to 5 volts, even on the signal side. So that you're just gathering up that information. So then we go here, and then these are the typical scan tool data. Same thing. Normal range is 1.3 to 1.7. Sorry, go back. So for the purge pump pressure sensor, this is the normal range, 1.1 to 1.4 volts on your scan tool. So now, this is the preliminary stuff. You go into your scan tool, you go look at the sensor, what is it reading? Because that tells you where you need to go in the tree. Alright? And then now, in this case, we're getting circuit low voltage for the purge pump. So low voltage is going to fall, basically would look like 0.01 volts. That's low voltage. 0 is an open. If you're getting some kind of reading and it ties into what it's showing you here, boom, you have an idea. So now, here's your descriptors here. I'm not going to go through it all. You guys can read it if you have access to ProDemand. But learn these things. Do your preliminary stuff. Grab the information so you know what you're looking at and you know how to approach this. Okay? So now, let me make sure I'm on the correct pieces here. 1. Alright, so here we go. We're going to carry on. If you guys have any questions, don't be afraid to ask. Because, I like to help. And people don't ask me for help. And that's fine with me too. Even if you have cars that you're having a hard time with, hit me up. I'll help you out. Anyway, so we're going to start with the system verification because this car is showing 0 volts. I verified that on the scan tool, 0 volts for the purge pump pressure sensor. Okay, so then we start here, ignition on, verify 641 is not set. It's not set. So if it's not set, you go to step 3. Here we are. Verify the scan tool data. It should be between 1.1 to 1.4. I have 0. But then my fuel tank pressure sensor is within specification. So now I cross this out because this isn't a problem. So I crossed it all out. So I can keep myself on track. It goes the next step. Only if the scan tool parameter is not within specification, refer to circuit system testing. So I went to step 4. Okay. If both are within the specified range, right here, read it, the value should not change. The wiggle test is just basically a test to see if you got a bad connection. When you wiggle the harness, your parameters, your data might start fluctuating, which means you get contact and you get non-contact. Okay, so verified is good. Wiggle test, good. So let's go to the next page. And I'm back to circuit system testing. Disconnect the pipe. Let me see. on the purge pump side. G58. So, GM, they list these modules by numbers. So you can look it up. G58 should come up as a veg per pump. Okay. Now, you read this. Verify scan tool. Is it reading between 1 to 1 to 1.4? It says if it is, you start here. If not, I circled it because it's not. It's at 0 volts. So, here, process ignition off, test for the 10 ohms between low reference circuit terminal 2. So now, this is one thing I forgot to grab when I do these diagnostics. I wanted to teach, but I didn't grab the, the connector, component connector. So it's going to look something like this. That's what the connector looks like. It's got 5 pins. 1 is right here. Number 1 is the far right pin. And then number 5 is the far left pin. So just imagine that's what the connector looks like. You're looking at it. So when it says, and then it'll go like this. Number 1 pin is right here, far right. Then work your way to the left. 2, 3, 4, 5. Okay? So where are we at? Terminal 2 and ground. Any kind of ground. Your black lead on your ohm meter, you can put it on the battery negative terminal. Any kind of ground. So what's your spec? What are you pulling? You know what I mean? Circuit number 2, terminal. So which would be the terminal left from terminal 1. And ground. What are you getting? What are you reading? It's less than 10 ohms. That's what I got. Okay, so now ignition on, service mode is basically ignition on. So ignore what service mode is because it's whatever. Now you want to test that circuit. Not that circuit, but now you're at terminal 3. You want to test that 5 volt reference circuit. And terminal number 2, which here, terminal number 2 is left from terminal 1, and then terminal 3 is left from terminal 2. You're going to test those 2 circuits, 2 and 3. And what are you getting? I got 4.9 volts. Now look at this, 4.8. If less than 4.8, then you follow this tree. Since it's not, you go over here. Next. It says if it's between, this is where I got it circled, 4.8 and 5.2, then you follow this tree, number 10. Okay? This is what I got. 0, 0. It's reading 0. It's not giving a signal. So now this is where this diagnostic test gets really fun. Because this will trip you out. That's why I like running diags, because it trips me out. Shit works awesome. So now we're here, less than 0.2 volts, which technically 0.0 is less. You get a fuse jumper, right? Do you know what a fuse jumper is? Imagine your fuse, right? Horse shape, whatever. This is your fuse. And then there's a wire that comes out of one end of the fuse, and then there's a wire that comes out the other end of the fuse. And you created a wire, a circuit, right? Excuse me. And then, so they tell you want a 3 amp fuse jumper. So the fuse that you want to use to make that wire is a 3 amp fuse, because anything more is going to carry more voltage, and you can fry that circuit, or you can cause problems. More problems than you need, than you're willing to deal with, because, hey, you're just running a diag. So it tells you connect that fuse jumper between terminal 1 and 5. Look at your 1 and 5. So 5 on the left, 1 on the right. So those 2 end pins, you're going to jump those 2. And now, what do you see on the scan tool? Look at the data for the purge pump. purge pressure pump. They're two separate things. It's not a purge. We're not talking about the purge solenoid. This is different now. This is added to that system, evap system. So, what's the scan tool saying? Well, I got a reading of 5 volts, flat out 5 volts, which means what tells you right there is that that circuit is working because you're getting a reading in the scanner, which only means that that purge pump is defective, correct? So now that's just the process of elimination. So now, if it's greater than 4.7, boom, test or replace the component. G58, we don't test it. We just tested it. Now, what they mean by test the component is if there is a component test. But if there is a component test, that's your back loop. That's the easy way to test it because, you could spend an hour on this testing every individual wire going down the tree. But if you have a component test, that tells you right there if the component is bad or not. But no, we're running circuit verification. We're basically wondering, is this wire doing its job or is it broke? Right? So we verified that the purge pump was bad. I swear to God, I've done like 3 already within the past 2 weeks. I had one that was reading, but it threw that code, the 146D. So of course, even in this test procedure, it tells you just ship the vehicle out because there's no issue at this time. That car actually came back yesterday. I verified it. So now I cheat now. I know the test procedure. So I just get my fuse jumper. I go to terminal 1 and 5. I look at the scan tool. If it goes up to 5 volts, I know the purge pump is bad. So now that you ran this, you just saved yourself an hour diagnostic. You can go straight to the nitty gritty, get straight down to the point, and you pinpoint it. And the second car that you get with the same code, you can go straight to the end. You see what I'm saying? So why not learn it now? Why not try to teach yourself? Because if you ask me, diagnostic techs are the baddest. Anybody can replace parts. When you become a diagnostic tech and you get really good at this stuff, that's when you got mad playing cards when it comes to your money. I hope this helps somebody. Like I said, this is what it's here for. Let's try to help you guys. I know shop environments, I had to work my way up. And the way I got my stripes was running diags that nobody wants to do. People, I ain't got no time for that. You know what I mean? I think that's a cop-out. Anyways, like I said, if you guys have anything that you guys are having a hard time with, hit me up, write a comment, make a model, what's your issue, and then I'll try to open up some context, and then, we could work through it. I can help you diagnose your stuff too without being there. As long as you can understand these systems, we can get it going. All right? Have a good day. Thanks.